Hello, everyone. This is me again. We're back in the lab, making searches, researching, and being very determined and focused to find a new way to bring in a new knowledge into the glass industry. Oh, Nekuku, yeah. Anyway, sorry for the distraction. Remember, my target is, or rather, the problem is that manufacturing glass, production of glass, consumes a lot of energy because of the presence of silica, which is sand. If you want, you can go and check the melting temperature of sand. That is very, very high. So that takes a lot, and that is one of the major raw materials, if you remember, in glass manufacture. Takes about up to 70%. That is a problem. Even when you add fluoxing agents, yeah, it tries to bring that down, but even at that, it still consumes a lot of energy. That is one problem. Another problem is that the use of carbonates, in my study, calcium carbonates, when it decomposes, um, while you utilize calcium oxide, the calcium, the carbon dioxide emission there, of course, if you know about global warming and all the effects of emission will have, carbon dioxide emission is one of the major ones that causes that. So, so the problem of energy consumption and CO2 emission from glass industry as one of the energy intensive industries is a concern to the whole world, is a concern to me, and that is why I'm working on this project. So that is me in the lab. Anyway, before I proceed, this is me here helping a colleague to pour glass from the furnace. You see how hot that furnace is, and that is why I had to wear the blue lab coat. The blue lab coat, or the color the colleague is wearing, they are all fire resistant lab coats. It doesn't mean that you have the liberty to enter into the furnace with the lab coat and you will not be burned. No, but like, it is more safety conscious, it is more protective, and our priority here is to make sure that we are all safe while we work in the hot furnace room. You see how I'm covered with my helmet, my Google, and everything that keeps me safe, my a thick hand glove. And yeah, that is me again assisting him, because you don't work in the furnace room alone, especially when you're working with high temperature. So that is me having the privilege to assist the senior colleague who is doing his work well covered and asking questions. Of course, at each point I am asking questions and asking questions. See, does that not look like a masquerade? Anyway, that is me. Yeah. um Opening up, because I just finished and I came out very glad that I was able to help man. My hair really very scattered, but anyway, that is me going back to my normal work. As I was telling you before, the colleague asked me to come and assist him. So that is me here back to my base and changing back to my normal lab coat. The white one is different from the blue one. I think I've said that before, because this is just a normal lab coat you use to get you protected from splashes, chemicals, and anything that could happen. Like, one of the main thing working in the lab is being safety conscious. So that is me here, um, making further searches in analyzing my raw materials to monitor. Of course, part of my work is that I keep monitoring their melting kinetics, I keep monitoring the way they react. So I do this through so many ways. I use the XRF, I use the XRD, I use the thermal gravimetric analysis, I need the differential thermal analysis, I use the macro CT and many other analytical techniques, just to identify each raw materials, the way they work and what they are in for, and how they will help my search. So basically, before now, I thought I've actually done, like, I thought I was graduating anyway. I thought I was finishing, but eventually, after with meeting with my team, both the professors and the doctors in there, we agree that there is something basic I still need to go back to the lab to do, and that is me doing what I need to do and what I'm supposed to do just to help the world. This is the target here is to help reduce emission so that we'll all have a better life, a better breath for us and for our generation to come. So that is me completing my work while I speak with my colleague who was asking me some questions. I am here to make sure that the flow rate for the fume cupboard is stable before I sign off and um, hand over to the next person. So that is me monitoring the flow rate. Of course, the flow rate has a standard. It needs to be maintained to be sure that all the gases or whatever emissions, anything that is the dust, coming out from while I measure or while anybody measures, is having a normal flow and is living as it should be without standing as a hazard, a danger to anyone. So that is me making sure that the flow rate is normal, and I hold that for some time to monitor it and to stabilize it so that I can take proper record and document it. But while I do that, I just want to say to you that it is fun being here. It is motivating seeing myself go this far. I'm telling you, I am a chemical engineer working majorly now with material science and engineers, but still having a big aspect of chemical engineering in what I do, because after my analysis, most of my work and my reports and part of what I will do will be a lot of enthalpy calculations, that is chemical engineer basis, a lot of rate reaction, kinetics monitoring, and so many things that are involved. Just to say again, I feel grateful, I feel proud that I am a woman and I am pushing this hard and I am not giving up, and I hope to finish this and I hope to stand up and I hope to rule my world. I encourage you to make a leap in case you feel tired or discouraged. You can look at me and I know you can. Cheers and bye.